Welcome. In this video walkthrough, we will guide you through building a complete use case on the Keboola platform. This specific use case was originally designed for the Snowflake Build conference in London. We'll cover everything from data extraction to visualization. Let's dive in. In this video, we will collect Google reviews of the London Eye from a MySQL database, process these reviews using Snowflake SQL transformations, enrich the data with a Hugging Face large language model, parse the LLM response with Python transformations, deploy a Streamlit data app to visualize the data, and build a flow in Keboola to automate everything, enabling scheduled runs. Let's start with data extraction. To begin, navigate to the Components section in Keboola and click on Components again to access the directory of available Keboola connectors. Use the search bar to find the MySQL extractor and select it. Next, click Add Component. We don't want to connect to any demo data right now. We want to connect to our real data, so we will click Connect to My Data. Here we can name the component Build Reviews, add some description if needed, and then just click Create Configuration. The first thing we need to do is set up credentials so that we know which database we are actually connecting to. Click Set up Credentials to do so. In the provided GitHub repository, you will find all these details and the entire tutorial, including screenshots and including all the credentials that you will need throughout this. Navigate there to find the host name and other details of the MySQL database. Make sure that we have entered everything correctly, test connection, and as soon as you have connected, click Save. Keboola will automatically use the provided credentials to try to connect to the source database, and it will provide you with a list of tables or objects that you have permissions to read with the account that you used. Now we need to select the tables that we actually want to extract from the source database. Expand this menu to select tables to copy from the source, and we will build the API reviews table. We don't actually have permissions to read any other table, but we might have in the future. Don't get confused why the table is named Appify Reviews. The reason is that we originally used an Appify service to scrape all the reviews of the London Eye from Google Maps. We don't, however, use the Appify extractor directly in this tutorial because we need this to be available to many students concurrently, and it's easier to do it from a MySQL database. Let us now proceed and click Create Table. Keboola created a so-called configuration row. So the entire configuration of the MySQL connector now has a new row that defines how we extract data from a single table. We can navigate to that row to see details of it. There is a possibility to edit incremental fetching or incremental loading into Keboola, which is something we would certainly do if we were running this on a schedule and only wanted fresh data every time. We might also use advanced mode if we want to use our own SQL query to define how we want to fetch data from the source. We don't need to change anything right now, so let's just click Run to execute the extraction job and then confirm clicking Run again. Now Keboola has executed a so-called job. We can navigate to Jobs in the menu to see a list of all executed jobs in Keboola, and then we can click the job we are interested in to see the full details of everything that is happening behind the scenes. This time we will not dive deep into this log, but we can see that Keboola is connecting to the database, locating the table that we wanted to extract, fetching it, uploading it into Keboola, and importing it into the database in Keboola, which in this case is, of course, Snowflake. It has now also created a table in a new schema in Snowflake and loaded the table into it. So there are some operations happening automatically behind the scenes, apart from just pure extraction. That's also why the first execution might always take a little longer than subsequent ones. As soon as this process is successful, we will see a new table in our Snowflake database. To make it easier, we will look into the Snowflake database through our Keboola Storage Explorer right now. Using the main menu at the top of the page, we can navigate to Storage, where we will find a new bucket, which corresponds to a schema in the Snowflake database. Within this bucket, you'll see a new table named Appify Reviews. You can expand the table to view its full details and metadata, including the last import date, the component configuration used for the import, and more. More interestingly, we can view a sample of the data, which includes many columns from the table. This dataset, extracted from Google Places, contains approximately 5,000 records. With this, step 1 is complete. We have successfully extracted the data from our source database and are ready to proceed with further processing. Let's proceed with step 2, which is data transformation. We have just extracted some, let's say, random data from Google Places, and we need to clean it a bit so that we can work with it further. Our intention is to use these Google reviews to actually analyze the sentiment and keywords of all those reviews that people leave. So we need to make sure that we're working with correct data before we actually send it to any large language model. We will use the top bar menu again, this time to navigate to Transformations and click Create Transformation. While we could use Python or other options for this step, we'll use an SQL transformation. We will name the transformation build 01 Data Cleaning. You may notice we are using square brackets as a part of our naming convention. Although it's a good practice to organize transformations into folders as your project grows, for now, simply click Create Transformation to proceed. The transformation detail page offers many configuration options, but for now, we'll focus on the basics. Retrieve the prepared SQL script from the GitHub repository, copy it, and navigate to the code block section. Click Add New Code and paste the script there. What we are doing here is fetching specific columns from the Appify Reviews table, filtering out rows with empty text, and limiting the subset to 500 records, down from 5,000, to optimize processing speed for the large language model. And once this is done, simply click Save. Next, we need to configure what Keboola refers to as input and output mapping. This step defines which tables we are reading from the database and which tables we want to write back into the database. Let's start with the output mapping. As indicated in our script, we are creating a new table named Aggregated Reviews. The transformation code is always executed in a temporary schema, ensuring isolation from production storage. Each time a transformation runs, Keboola reads the production data, executes the script in this temporary schema, and then uses the output mapping to define which objects from the temporary schema should be brought back to the production or main storage, along with the necessary configurations. To proceed, click New Table Output and enter the table name exactly as it was referenced in the SQL script. For the destination bucket, use Reviews Data Cleaning instead of Build 01 Data Cleaning. Simply type Reviews Data Cleaning in the field and click Create Bucket. We might switch to incremental loading or set primary keys, but we're not concerned about that right now, so we will just click Add Output. Because in our script, we haven't really provided an absolute path to our source table. We just said from Appify Reviews without specifying the schema. We need to specify this on the table input mapping. So we click New Table Input, and we choose the table that we want to use. At the moment, we only have one table in our storage, so it's simpler. Just expand and click Appify Reviews. We don't need to worry about incremental reading either, so we'll just read the entire table. Once we have added the table clicking on Add Input, we have all we need to run the transformation: input, output, and the code which builds it. So we can just run the transformation and confirm by clicking Run again. Another job has been executed. You can view all related jobs directly on the configuration page or navigate to the jobs section for a detailed view of the job's progress. At this point, we can see that a new output has been created in Snowflake. So there is a new schema and a new table, and below we will find the details of everything executed during this transformation. Let's navigate to storage again to see our new table there. We have a new bucket, which means a schema, and a table named Aggregated Reviews with all the metadata and a data sample. As a result of the transformation, we now have a variety of reviews in different languages and varying levels of detail. To gain deeper insights, we need to use a large language model to translate these reviews, extract keywords, and analyze sentiment. This will help us better understand what people are saying about us. While relying on star ratings might seem sufficient, they often lack the context needed for a more accurate analysis. So we will use the generative AI component in Keboola to enrich this data with large language models. To do this, we navigate to Components again and click Add Component as we are about to add a new component. Here, we will search for generative AI. Once we find it, we'll click Add New Component, followed by Connect to My Data, as the data has already been prepared in our transformation from the previous step. Last but not least, we'll give the configuration a meaningful name, let's say Build Sentiment Analysis Keyword Extraction. The first step is to decide which AI service provider to use. For this case, we'll use Hugging Face. While similar results could be achieved with Snowflake Cortex, which has been demonstrated extensively, we aim to showcase alternative approaches. Specifically, we are leveraging Keboola with Snowflake powering all the transformations in the background. You'll find the required API key for the Hugging Face model in the GitHub repository. Enter the key and click Save to proceed. We've now completed the default part of our component configuration, much like when we entered credentials for the MySQL database. In this case, we've provided the credentials for the generative AI component, enabling it to connect to Hugging Face using the API key. The next step is to specify exactly what we want to accomplish, defining the data to use, selecting the model, and designing the prompt. Click Add Row to our configuration. We will name it Sentiment and Keywords, then click Create. The first step is to specify which table Keboola will use for sentiment and keyword analysis. Begin by clicking New Table Input and locating the aggregated reviews table that we created earlier. With the API key now configured, we can access the list of available models on Hugging Face. Once the current list is loaded, the next step is to expand it and choose Custom Model, as we'll be using a custom model deployed specifically for this task on Hugging Face. Enter the endpoint URL provided in the GitHub repository. Then, set the max tokens value to 500 while keeping the other settings unchanged for now. The most important part is defining the prompt. This determines how the component processes the data. When we execute this component, Keboola will take each row from the configured input table and send specific columns to the model as part of the prompt. For every row, in this case, every review, the model is called using the defined prompt. For this tutorial, the prompt has already been pre-designed. You can simply copy the prepared prompt from GitHub and paste it into the configuration. Our prompt instructs the model to perform 3 tasks if the text is not in English: translate the text, extract up to 5 keywords or phrases, and evaluate the sentiment of the translated text on a scale from -1 to 1. A score of -1 indicates very negative sentiment, while a score of 1 represents very positive sentiment. To help the model interpret sentiment accurately, we include examples in the prompt, such as I love this, which equals to 1, and I hate this, representing the -1. We also require the output to be structured in JSON format with fields for text in English, keywords as an array, and sentiment. Since the prompt specifies process the text below, we use a placeholder to insert the review text from the text column of each row. We set token spend to 0 to avoid a token limit. The results will be loaded into a new storage table named Processed Reviews. For now, we won't configure incremental load or primary keys. If the prompt hasn't been pre-designed, you can use the Test Prompt button to experiment. Clicking it makes Keboola call the model with 5 random sample records from the input table and displays the results. This is a helpful way to verify that the model and prompt are working as expected. In the results, you'll see the text in English, extracted keywords, and a sentiment score. Everything looks good, so we'll scroll up and click Save. Now let's execute this. We are now executing the generative AI component, which calls the large language model on Hugging Face to process our reviews. For the subset of data and the specific model we're using, this process might take around 10 minutes. To save time, we won't wait for it to finish. Instead, we'll use some data from another project that has already been processed. We can fetch this data via the data catalog in Keboola. Navigate to the data catalog, where you'll find a bucket from the generative AI component, likely named Reviews Processed by AI. This is probably the data we need. After clicking on Use This, keep the name as is and click Link. After that, navigate to Storage, where you'll see a new bucket that we just linked containing a table named Processed Reviews. By clicking on the table, you can view its basic details. Let's take a closer look at a data sample to understand how the process table appears. The table includes the original data along with a result value column generated by our model. This column contains the repeated prompt followed by a JSON object which we'll need to parse. Next, we'll use a Python transformation to remove the repeated prompt and extract the JSON content into separate columns in a new table. Let's navigate to Transformations. Click Create Transformation, and for demonstration purposes, we'll select Python. Although in practice, we could parse JSON directly in Snowflake as well. We'll name this transformation Build 0 to Process Reviews Parsing, leave the other settings unchanged, and click Create Transformation. As you'll notice, this process is very similar to the SQL transformation we performed earlier. It involves input-output mapping and a script. First, we configure the input mapping. We'll say we want to read the table processed_reviews that we just linked from the data catalog. Then we will click Add Input. Next, we'll copy the Python script from our GitHub repository and paste it into a new code block. We will not go through every line of the code now, but the process is straightforward. The script processes the result value column by removing the repeated prompt, parsing the JSON content, and creating new columns in a table. These columns include text in English, keywords, and sentiment. Additionally, the script generates another table that aggregates keyword counts, allowing us to quickly identify the most frequently occurring keywords. After pasting the script, click Save. Once you close the code block view, you'll need to set the output mapping as only the input mapping has been configured so far. We'll be reading from the table named Processed Reviews. In Python transformations, data is written out as CSV files. We named these files in the script, so the output file names must match exactly to ensure Keboola stores them correctly in storage. Click New Table Output and enter the file name used in the script, for example, reviewsparsed.csv. Next, place the file into an existing bucket called Reviews Data Cleaning. Repeat the same process for the file keywordcounts.csv. Your transformation should now look like this: one table specified in the input mapping, and two table outputs, reviewsparse.csv and keywordcounts.csv. Ensure that the input mapping references the correct table, and that both output file names match those defined in your script. At the bottom of the configuration, verify that the Python script is pasted correctly and saved. Double-check the input-output mappings and confirm that the bucket names are accurate to avoid any errors during execution. Once you have reviewed everything and ensured all settings are in place, click Run to execute the transformation. You can monitor the process on the Jobs page to confirm successful execution and inspect the resulting data tables. You can navigate to the Jobs page for detailed information about all executed tasks. Here, you'll notice that our generative AI job is still in progress. Additionally, a new job has appeared at the very top of the list. This is the Python transformation job we just initiated. Let's open this job to review its details. Here, we can already see that the new table in storage has been created and populated with data. Scrolling down reveals the full details of the job, including everything that was executed within the transformation. However, let's not focus on the job details for now. Instead, let's shift our attention to storage to verify that the tables we created are located where we expect them to be. Expand the Reviews Data Cleaning bucket, which, as you may recall, is where we specified the output tables to be saved. As you can see, two new tables have been created: keyword counts and reviews parsed. These tables were generated by our Python transformation configuration. Clicking on the Reviews Parsed table opens its detail view where we can examine the data. The data sample provides a clear confirmation that the output matches our expectations. We can see columns for the translated text, sentiment category, and more. This structured data set will make it straightforward to create visualizations and gain insights from the data. There are some very nice examples of the reviews we collected. For example, great experience. First thing in London, excellent view, or mentions that it may be a bit costly thing to do in London. Well, but for our purpose, we will avoid analyzing the data in here and keep that into a data app that we will build for such purpose. We will use Streamlit in the next step. You might think that the traditional approach would involve performing exploratory data analysis first, using charts to understand the data, before deploying a dashboard or an app. Of course, that seems like the logical approach, but let me fast forward a bit and show you just how quickly we can build a data app. First, navigate to Components. However, instead of directly clicking on Components, select Data Apps from the drop-down menu. Then click Create Data App. We will name it London Eye Reviews Analysis, and click Create Data App. You could start from scratch by writing your own Streamlit script. Generally, you can store your code in GitHub or even directly in Keboola, similar to how we did with Python transformations, and I fully encourage you to explore this approach. However, for this particular case, we have already prepared a script for you to start with. In the GitHub tutorial, you'll find a repository URL. Copy and paste this URL under the deployment section. After adding the URL, we can click Load Branches, and once the list is loaded from GitHub, select the appropriate branch. In this simple example, we'll choose the main branch. After that, we will specify app.py as the main file path and click Save. You may have noticed that there are other options available during the setup of the data app that can be fully leveraged if needed, such as authentication, an important feature, wouldn't you agree? For now, we are leaving it disabled, so the app will be publicly accessible. But if required, you could enable OIDC or basic authentication for added security. Additionally, you can use the secrets interface to manage credentials securely, keeping them out of your code. At this point, we have specified where to retrieve the script and how to configure the application. That covers everything we need to do for now. Therefore, we will proceed by clicking Deploy Data App. There is an option to select the backend size for running the app. In this case, an extra small backend is sufficient, as we are only visualizing a few records of data. Another configurable setting is the inactivity timeout, which is set to 15 minutes by default. This means if the app is inactive for 15 minutes, it will automatically go to sleep. When someone tries to use the app again, it will be restored, which typically takes up to 1 minute. Let us proceed to deploy the data app now. Keboola will spin up a container and host the Streamlit application. If needed, you can monitor the progress of each individual step during the deployment. Now, once the deployment is complete, the status on the configuration page will change to active. You will also see a new button labeled Open Data App. Let's click it to access the application. If you were to examine the app's code, you would notice that it connects directly to Keboola storage through Keboola APIs. The code explicitly specifies table IDs from Keboola storage, which allows the app to retrieve the necessary data seamlessly. This approach ensures that the app works dynamically with the data stored in Keboola's environment. To make this process more efficient and maintainable, it is recommended to name your tables and buckets in a clear and consistent manner, as demonstrated in this example. Using intuitive and descriptive names makes it easier to navigate and reference your data, reducing potential errors and saving time during development and debugging. This practice also improves collaboration, especially when multiple people are working on the same project. The app includes filters for both negative and positive reviews, allowing users to explore the data from different perspectives. It provides visualizations of sentiment score distributions, highlights the top 10 keywords by count, and offers other valuable insights. For example, view emerges as the most frequent keyword, reflecting its importance in the reviews, while expensive is another common keyword indicating cost as a significant point of discussion. Interestingly, the model extracted both worth and worth it as separate keywords. This suggests that the prompt used for data processing might benefit from further fine-tuning to improve keyword aggregation. Such adjustments could ensure more consistent results and provide clearer insights into user sentiment and preferences. Let us scroll further down to explore the data itself, translated into English, and a word cloud. The dashboard is fully interactive, enabling users to quickly filter and view all positive reviews using the master filter at the top of the interface. Conversely, you can use the slider to focus exclusively on a range of negative sentiment values. As you may recall, this represents negative feedback, allowing us to concentrate specifically on unfavorable experiences reported by users. It becomes evident that many of these negative reviews are commonly related to the cost, highlighting it as a recurring concern among users. Now let us flip the filter to positive values and explore the positive experiences shared by users. It may take a couple of seconds to reload the data for visualization, but once loaded, the most frequent phrases appear. 30 minutes, 45 pounds, great concept, great place, beautiful 360 view, and many others. Since the app has no authentication, its URL can be shared with anyone, making it easy to collaborate and share insights. We have now completed building all the steps. Let's finalize the process by bringing everything together in an automated manner. We'll build a flow, which serves as a data pipeline that defines the steps to run in sequence. Our goal is to execute everything sequentially, either on a schedule or based on a trigger. To do this, navigate to Flows, click Create, and name the flow Build, Extract, and Deploy App. Once named, click Create Flow. Select the first step of the flow, the MySQL extraction configuration we built earlier. The process is simple. You need to select a component and then choose the specific configuration to be used in the given flow. The second step of the flow is the SQL transformation, which cleans the data we extracted. After that, we will call the generative AI component to enrich the cleaned data by using advanced language models to extract insights, perform translations, and analyze sentiment or keywords. Then we process the data using the Python transformation, which parses the LLM responses. Finally, we add one last step for the data app deployment itself. While the data app has already been deployed and will function as configured respecting the timeout limit, it will always be redeployed if accessed via the URL where it is hosted. However, when the app is part of the flow, Keboola ensures that during each flow run, it checks whether the app is deployed. If the deployment has been canceled or deleted, the flow will automatically redeploy the app, maintaining its availability. Now, have a look at what our flow looks like. You may have noticed that it is purely sequential. While the flow builder in Keboola supports running multiple jobs concurrently, in our case, each step is fully dependent on the previous one. As a result, there's nothing to run in parallel. Therefore, we can proceed by clicking Save. Now we can either run the flow manually or assign it a schedule to automate its execution. By clicking Create Schedule, we can access a comprehensive set of options to configure the timing and recurrence of the flow. For a quick demonstration, we might schedule the flow to run daily at 8 a.m. UTC, ensuring that it processes and updates data consistently every day without manual intervention. Additionally, you have the flexibility to add multiple schedules or triggers using events, the API, or other advanced mechanisms available in Keboola. These options provide robust customization for workflows tailored to specific operational needs. For now, to keep things straightforward, we'll proceed with this basic setup and save the configuration for our demonstration. This is it. We've successfully developed a comprehensive use case in Keboola. Within this walkthrough, we managed to extract Google reviews from MySQL, clean them using Snowflake SQL, enrich the data with a Hugging Face LLM, process the LLM results with Python, and finally deploy a Streamlit data app to visualize everything. This end-to-end solution highlights the power and flexibility of the Keboola platform for data-driven workflows. Inspired by what you saw? Discover more possibilities and connect with us at Keboola.com.